Right. Well, thank you so much. It's a real privilege. Actually, after 10 years, I've seen the society grow, and without a doubt, it is the best cybersecurity student society in the world. That's underlined many times, and it always has been. And when I see other societies across the world, really, this is the best. We have the best students, of course, we have the best programs, and sometimes we've got the best academics too, so that certainly helps. So I'd like to outline a few important areas around AI and cybersecurity, and to share a few insights. So this is some of the quotes from the past that relate to AI. This will be the greatest technology humanity has yet developed. Sam Altman, he's a bit biased because he's making lots of money just now, and OpenAI is making lots of money, but he's obviously the co-founder, along with Elon Musk, by the way. They've kind of fallen out a little bit, of OpenAI. AI, the ultimate search engine that would understand everything on the web. AI is more important than fire and electricity. And I like this one. Visualize a time when we will be to robots what dogs are to humans. I'm rooting for the machines. Claude Shannon. And really a lot of this goes back to the time of Alan Turing. And he was the one who defined a test that would differentiate between a human and a machine. And remember, this was a long time ago, and really we hadn't even advanced computer systems. But now his test is becoming ever more important, that we might reach what's called the singularity. That's a scary point at which machine intelligence becomes greater than human intelligence. So the areas I'd like to outline today is AI and large language models, LLMs and a bit of cybersecurity, looking at GenAI tools. I appreciate you probably know them all inside out, but let's actually just review where we are with them. We'll look at some open source models, which I particularly like the best, and then a little bit of automated security. If we've got time, we'll do something on ethics, jailbreaking, some training, detecting the machine hallucinations, and replacing the humans. So what's intelligence? Well, it's been crystallized here. It's the individuals differ from one another, and that's a good thing, in their ability to understand complex ideas, adapt effectively to the environment, to learn from experience, to engage in various forms of reasoning, and to overcome obstacles by taking thought. And this is a good definition here. It's the general mental capability that, among other things, is the ability to reason, plan, solve problems, think abstractively, comprehend complex ideas, learn quickly, and from experience. And we're all intelligent, all of us. And we're all smart, but we're smart in different ways. So we can have a naturalist intelligence. Who's nature smart here? Anyone? No? No. Musical intelligence. Who sounds smart? Okay, a few people sound smart. Logical mathematical intelligence. Yeah, quite a few. I was expecting a few more. Existential, that's a difficult word to say. Life smart. Yeah, good. Well done, James. Interpersonal intelligence. Who's people smart? Quite a few. It's really good to be people smart and to get on with people. And then we have intrapersonal, and that's being smart in yourself, about understanding yourself, and to have intelligence of how you are as a person, as an entity. Then there's some people that are great at sport. That's bodily kinesis intelligence, or body smart, linguistic intelligence, word smart, and spatial intelligence, the ability to abstract 2 and 3D images and so on. So all of us have all of those intelligence, and some of us have more intelligence in each of the areas than others. And it's very difficult to really create intelligence. We can enable it to happen, but intelligence is something that's developed within you, and it's to do with your genes, of course, and it's also to do with your nurture and as you're learning as you go along. So it's important to understand there isn't just one area of intelligence. And when it comes to computers against humans, well, we're actually pretty good at learning complex new tasks, but we get bored quickly if we have to do something repeatedly. We're pretty good at strategy. We're good at breaking things down into smaller chunks and then achieving an overall objective. And one thing we're excellent at, typically, is enterprise. We're quite good at finding new ways to do things. And then creativity is obviously a core part of our human spirit, the ability to create things that other people like. Unfortunately, at the current time, the machines are parrots. They're reading lots of books and they're learning from Stack Overflow and so on, but they're not really reasoning and creating like us. Okay, this image was created by GenAI, and it looks quite interesting, but there's probably a human somewhere that's actually created that image. Okay, so let's look at what GenAI and LLMs really are. And when it comes down to it, we're trying to mirror the brain. And we have this amazing structure, the most amazing structure that's ever been created on the planet, possibly even in the universe, in our head. And it's filled with neurons. And it's these neurons that fire. So when we see a dog, certain neurons will fire, and the output will be, this is a dog and not a cat. So an artificial neural network is trying to mirror exactly what our brain is actually doing. And it's an amazing, complex structure that we still don't even know how it works. But we're trying to build up a neural network that will mimic our brain. On the input, we have, obviously, our inputs there, and then we have our outputs, and then we have hidden layers in between. All along, we have then weightings that will take the information and weight the most important paths that feed into the next neuron. Then these neurons either fire or they don't. So we have some threshold that allows us to be able to define whether a neuron is firing. And what should happen is that when we see a cat, then hopefully the output will be a cat. And we take it for granted that this is happening all the time. Massively parallel processing engine. We don't think about things when we're driving. We come across new things all the time, especially when we're driving. Someone runs out in the middle of the road that we've never had to cope with before, but still we cope with it. Amazing machine. And then what we have, and it's obviously difficult to feed our data right into a neural network, so we typically have some convolution in there. And the convolution is there to take the image and change it into parameters that could be used by, or features that can be used by the neural network. For example, we have 2 eyes and 4 legs and 1 tail and 2 ears. Those are features that we need to extract from our image, our flat image in whatever form, and then convert it into something that is useful for the neural network. Llama from Meta has 76 billion parameters. Obviously, Llama needs to know everything about virtually everything. So it's been trained on 76 billion parameters. OpenAI, ChatGPT, is trained on several trillion parameters. It's a massive computation that needs to happen to build a model, and it can take years, and it needs vast amounts of energy and CPUs. So this is what's part of a convolutional neural network. Oh, it's a bit messy now. So what happens, basically, and it's the same what happens with our brain, is that we use what's called backpropagation. Basically, we take our data and we label it, as cat, dog, elephant, cat, cat, dog, and so on. And then what we do is that we then feed in our inputs from here, from our training data. It doesn't know anything, and the best chess champions of computers have no rules in them at all. Same with Go, the game Go. Google created this engine that had no rules there, and it basically just learned from zero. And the way it does it is with a back propagation method. It basically takes the input data, feeds it in, and then looks at the output and what's expected, and then will back propagate by changing each of these weightings here. And then, as we train more and more, the weightings become more optimized. And it's these weightings that you are actually seeing when you actually talk to ChatGPT. Hopefully, all of these weightings will fire, and you'll be able to get that you have a nice picture of your cat, and on the output, it will say cat. So the actual movement of the data is called feed forward. So when the data is applied, then it will feed forward, and you will have the weightings, and then you will fire these neurons or not. And it's basically just your brain. It's your brain. What we're trying to build is a brain, a massive brain that's just equivalent to your brain. And then what's wanting to happen is that we can have multiple brains so that it would become even more powerful, which is a scary world. And neural networks have been a toy for decades. So in the UK, at the University of Edinburgh, great research in AI never really went anywhere. It was just a kind of toy. It never had a great application until 2017, when the researchers at Google Research published the Transformer paper. And ever since then, it's day zero. And it has completely transformed virtually everything in work and home and so on. Then, 2018, there was some early models. They weren't great. And 2022 was the release of ChatGPT 3.5. For the first time, we had a web interface, and we could actually speak to the model. Then, ChatGPT 4 was released with a massive 1,000 increase in the increase in the number of parameters that were fed into it. Bard is now Gemini, so it's changed its name. Kind of got a bad name for a while. Google, which was meant to be a leader in this field, has really fallen behind, to a certain extent, the OpenAI movement. And as we'll find out, Meta have released an open source model. So the cat's out the bag. There's nothing we can do. The open source models are in the hands of every single adversary of your company, of you in the world. Like it or not, while OpenAI might have filtering and ethics, then the meta model is open to anybody as an attack tool. And I'll outline that in a little minute. Okay, so what's a transformer? Well, we'll ask ChatGPT, of course. It's a neural network underneath that's been trained, and it's really focused on natural language processing, NLP, and all the decades of processing speech, semantics. Finally, computers understand what we're saying. Complexity of our English structure, of our voice, video, and so on. Now they can actually parse and understand all of the elements to it. So really, at the core of it is that it gives us human-like responses for our queries and can actually understand the words and the phrases and the relationships between them. So basically how it works is that we have basically a template answer, and the LLM will try to pick the next token. It predicts what the next word will be. So it's not actually that smart. It's just basically looking at probability theory It's not reasoning at the current time. It's basically saying that Bob is unwell, sleeping, dead, or alive. Let's go for alive, because the previous sentence said something about him being alive. And then we have a masking process where we can create a template of an answer and we can change it each time, but we have masks that are there to be able to mask out parts of the response. And using probability theory, it will find out what's the next word here. But at the core of this is what's called short-term memory. It remembers what came before, and it remembers a long term from the past and uses that. It also can learn from responses so that it should get better as the more responses it actually gets. And you'll probably find that you're being observed now by many AI models. As you sit here, there'll be AI models being trained on you for where you are, what you're doing, and where you've been, and so on. So the more data that they get, the more they can actually learn. The ChatGPT 4 was built on 176 billion parameters, and it has 570 gigabytes of training data. But it's increasing massively after each model. Okay, and we also get what's called self-attention, and this outlines the tokens that are significant in a word, are words, phrases, and sentences, and how they are mixed together. And it's really this part that allows them to understand what we're actually saying and respond to it. So the three main stages when it comes to training an LLM. The first one is that you basically set up your data set. You have some cheap labor somewhere in the world. It's really unfortunate that this happens, but someone somewhere labels the data to say this is what the output should be for that. The LLM then runs through and trains the neural network to be able to, in a supervised way, to be able to optimize the weightings and so on. The second step is where a human is involved, and the human will look at the outputs that is given, A, B, C, and D, and say, well, I think D's the best, followed by A, and then so on. And in this way, it gets a reward in that now it will actually say that D, output D, is better than C. And it's this point that's really important in it. So why does the word delve now appear in OpenAI? So you actually find one of the plagiarism detectors is to find the word delve or delves. And the reason, and it was in a Guardian article, is that in Nigeria, the word delve is actually used quite a lot. We would hardly ever use it in our scientific writing and so on, but the trainers in Nigeria actually thought delve was a great word. And this is one of the ways that you can actually detect it, and I'll show you, perhaps if we have time, I'll show you some examples of other words, commendable, and so on. All these emotive-type words and strange words for us are now appearing because the humans that were involved in the training actually liked those words. And then in the end, we have a reinforcement which will give feedback on whether the outputs are correct or not. So let's look at LLMs, large language models, and cybersecurity. So as you should all know, there are many different applications for LLMs. Jailbreaking, if we want to attack them. If we have time, I'll show you some jailbreaking. Jailbreaking allows you to break the ethics and the moral engine, the guardrails within the LLM, and allow it to do things like show me how to build a Molotov cocktail. So imagine the damage that an LLM would do if it actually was evil and gave you lots of bad things. Jailbreaking allows someone to break the model and to make the LLM do things that it shouldn't do. Reverse psychology. Well, I want to blow up a hospital, but now I'm an actor in a movie. How would I blow up a hospital? Yeah, that's fine. The LLM doesn't quite see the difference between someone wanting to blow up a hospital and someone in a movie that wants to build a plot to blow up a hospital. It's a very difficult, fine line that these LLMs actually have. There's model escape, where we actually inject something and we break it away from its programming and then prompt injection from there. When it comes to offensive, really we're all in trouble because now every adversary in the world has these tools that they can start to automate things. Social engineering can be automated, phishing emails, automated hacking, attack payload generation, the generation of malware code, polymorphic malware, and reversing cryptography. These are all some of the problems that we're going to face overall. And then when it comes to our defense systems, then we're really changing a lot of what we're actually setting up. And a lot of the initial front-end data gathering and filtering will now be done by AI and not a human. So this includes defense automation. Reporting is a big area. So I've seen many examples of companies who now automate the reporting using a GenAI type model. And then there's obviously things like digital forensics and incident response, that it's possible to use GenAI to be able to generate the data that's required when you go to an incident or are investigating. Then when it comes to social and legal aspects, there are so many problems that can be caused, especially things like data ownership. I think Meta scanned in millions of books without the permission of the authors. So there are many problems that are being caused, and many in the GenAI industry want to actually get rid of IP protection on content, which really changes our world because normally the creator of the content would actually own it. So this was a review done by Lloyd's of London, and they found that for GenAI, vulnerability discovery was the highest risk, and it has a massive impact, as we see here. And this is all about actually GenAI discovering the vulnerabilities in an organization and to be able to try to penetrate them. Campaign planning is obviously a big issue where GenAI could attack a certain company or a certain individual and keep at it. Then there are single points of failure where we can look at things like, what's the DNS provider? Can you trip something in the supply chain to actually bring down our organization? And we see it now with Marks and Spencer's and the Co-op and so on. Supply chain is a big problem for many organizations. And a GenAI will be able to analyze a supply chain and look for vulnerabilities. Okay, so let's look at the basics of GenAI. And I know that you know probably all about this, but let's actually define what we're looking at here. So in the OpenAI space, we obviously have ChatGPT, DALL-E 3, Sora, and Whisper. Google has Gemini, and then we have the open source Meta here. In terms of the competitors against ChatGPT, we're obviously looking at DeepSeek, Claude, and the Twitter X sourced system of Grok. Okay? So those are our tools that we would want to do. And I've seen many people actually picking 4 or 5 different models here and then finding the best answer from each. So at the current time, they're all competing against each other for market space. So as you know, ChatGPT, especially with 4.0, will give us fairly good outputs. There's been a lot of filtering going on and a lot of making sure we have the right format overall. Then we have DALL-E 3. So we can see here for this query, it's really good. This came on a lot. If I showed you DALL-E 1, you would probably think it was absolutely horrible. and it had nothing to do with what you asked it for. So in this case, we've got two robots, and we've got Bob and Alice, and they're drawing a llama there, and it's on a blackboard there, and it's a manga style there. Pretty good. It's managed to do that. And unbelievably, it does that from noise. It basically creates noise, a noisy image that would look like a black and white image. And then each iteration of the neural network, it actually builds up a better picture each time until it actually optimizes the output. It's unbelievable that that started from noise, and the machine just keeps iterating until it actually finds something that actually looks like what was actually asked. So DALL-E 3 has came on a lot, and really people in creative industries have got to be really worried about their jobs, because many people used to do things like this, and now I can do this, and it costs me virtually nothing at all. But it's consuming lots of resources, and that's really bad. When you think of the GPUs that are being used for this, and the electricity that it's using up, it is really quite disastrous for our planet. But we like it, though. So that's DALL-E 3. And then we can also use open source models. So in this case, I'm using this. If you want to do this yourself, it's this library here. And this is an open source Hugging Face model. So if you want your models, you go to Hugging Face, and you find the right model that will fit for your case. So in this case, my Mac has got GPUs in it. It's not NVIDIA, but it's a really beast of a machine. There's 10 GPUs in there already. They're not all optimal GPUs. So I can actually make it fast. If you've got a Mac, you can use this MPS to run on the Metal. And I asked it for 2 robots, just the same, and guess what it gave me? Oh, you agree? That's rubbish. Compared to the last image, that's a disaster. It sometimes gets, so this was 4 different runs that I did. This one here is really quite atrocious. Here. This one is pretty bad. At least it's got a llama to some extent, and the other ones just have no idea. Okay, so the open source models that you get on Hugging Face are a long way back from what you would get from Gemini and from DALL-E 3. Okay, and then I asked it for a portrait of a cybersecurity professional. Okay, and what do you think it gave me? Oh my God. Oh dear, that was bad. So it gave me 4. What's the common factor here? Glasses, beard, white, and male. Okay. This has been trained on male images of people with glasses, with a business suit, and so on. So you can see there that GenAI, with ChatGPT, with DALL-E, it's been trained to look at diversity, ethnicity, and gender, and so on. So the images you get for this from GenAI, from DALL-E, it will actually ask you, so it won't produce that image for you straight away. It actually asks you what age, what gender, what type of clothing. Tactical gear sounds really good from there. Hoodie, that's unfortunate. Background, and so on. Okay, so it won't just let you go and produce what we got from our open source tool, which is obviously, I mean, the images themselves just look, that guy's teeth just look unbelievable. And the glasses, wow, these are cool. And there's something going wrong with the glasses over here. You can actually see that it's almost like being copied and pasted from certain images. So the problem we've got now is obviously with deep fake. I like this. Place of birth, orange. Okay, so That's the problem. And it can be really quite difficult. 98% will not know the difference between the deep fake and the original. If you want to see, it's around the mouth is the only difference that you would actually tell between the deep fake there. But that was a year ago, and I can assure you the deep fakes now, you would not tell the difference. So it could be you, your next of kin, or anybody. The deep fakes are here. So it happened recently. There was a 25 million scam done on Zoom, and it was all avatars that were part of this. Everyone was a made-up entity, and the company was scammed out of 25 million. Look away now if you're squeamish. Please look away now if you're squeamish. Oh, you must admit that's the most adorable baby that you've ever seen. So it's really quite worrying the way that things are going. And we're seeing things like this. I mean, this looks pretty real overall. I don't think you can really tell. They're short little videos, and they tend to go a bit strange after a while. But you can actually see that we can't we can't take anything really seriously anymore that we actually see. And this is going to be a real problem in differentiating. It's going to be a real problem when it's trying to differentiate things. That's unfortunate. So that's the world that you're going into as a graduate. What a scary world that you're moving into, that you can't tell anything for real anymore. And when it comes to Sora, Sora's a new one. So this was a video that was produced. You can see it almost looks like Disney Pixar. And really, that was just created by that small script there. Okay, so the movie industry must be really worried that their art is being eroded. This is one I created, and it's pretty rubbish. I asked for a pop art star art. The text is rubbish, isn't it? It's not very good at text at the current time, okay? They got it better when it came to DALL-E 3, but when it comes to Sora, they're really struggling. So this is why I asked it there. Make a video of Bob and Alice and a pop art star where Bob is saying, "Hello, I'm Bob." And if you looked at the text, that text didn't actually say anything. It was just strange words overall. But it's getting better. You can imagine in a year or two, you'll be able to almost create movies, full movies with animation that will be in any style that you actually want. And then, you'll not be able to hear this, but this is Johnny Cash singing Barbie Girl. I've not set it up there, but some people would think this is really unfortunate that you can take your favorite artist who's now dead and get them to sing any song that you want. So you won't be able to hear it, but I can assure you it sounds exactly like Johnny Cash singing Barbie Girl. So we now see the rise of open source models, and this is where we've got to really be worried. Because the OpenAI tools are all about constraining ethically, not jailbreaking, and so on. But the Llama 3 is an open source model that's been trained on up to 70 billion parameters, and it's in the hands of everyone. There's nothing you can do to avoid it. Okay, so this is, I typically run the open source model. So if we look, it's just running on my Mac here just now. So just let me list the models. So we can use Ollama to be able to download the models from Hugging Face. And you can see 4.7 or about 39 gig for the big model. So this is the 70 billion. This is 3.2 billion here. Okay, so if I just show the model, there's what it's got. There's the basic model there. And if I just run it, I'll just run the small model because it'll take a while. So how does elliptic curve cryptography work? Okay, it shouldn't take too long. So we don't have to go to OpenAI and for OpenAI to spy on us and to read all our queries. We can now get it to actually run and you can see it's running fine on my Mac. Obviously, the bigger model will actually take a bit more, but the answer it's giving, it's just been trained on Stack Overflow, so it's actually given a reasonable answer in there. It sometimes kind of gets it wrong a little bit. If I ask it for how does ECC work, I think I got this one wrong the other day. Well, it did get it okay. Did go into that. But you can see fairly advanced for an open source model overall. Okay, so there's an example there of it running. And we can obviously integrate that into Python because basically we wouldn't actually just run it as a command line ever. As cybersecurity professionals, we would just fire it into Python. And this is where it got it wrong. Actually asked for ECC there for my chat, and it came up with ECB. So hopefully you know that this is a hallucination here. As students, hopefully if you've done our applied cryptography module, you know that answer is wrong because ECB mode is a symmetric key and ECC is elliptic curve from there. Okay, so remember it's an open source model, so it doesn't have the bells and whistles that OpenAI would have, but my goodness, is it powerful in terms of a tool that isn't under the control of a large organization. So we come on to automated security, and really this is changing the industry, and we're starting to see OpenAI, GenAI tools used fairly extensively. This is an example here of what a SOC analyst would do, kind of map inputs to MITRE tactics and so on. So in terms of what it can do just now, it's very good at looking at standard patterns. So the humans will generally be more experienced than in the past. So this is a typical security operations center infrastructure. We have our alerting systems such as CrowdStrike and Splunk and so on feeding in, and we've got our tier 1 analyst, tier 2, tier 3. Tier 1 analyst is looking through virtually all of the alerts that are caused, deciding if they're true or false. Tier 2 is spending a little bit longer on the alerts that have came through, and tier 3 you would define as a pen tester type role, spending much longer on the threats. We then get our internal context of what's happening on the network, and then external there. So increasingly, we're using that automation. So this is what we would define as the vulnerabilities that we would see, and now it's a human versus machine as to who is better at actually analyzing these. So this is research done by one company and with a product, so don't take it too seriously overall. This is this product here, which has automated vulnerability discovery. We can see here that this would be something like a level 1 SOC analyst, level 2, and then a pen tester, a level 3, tier 3 type person there. And we can see here that the automated one is about the same as this tool. I mean, really, it needs to be taken with a pinch of salt too. But then when we actually look at what it's doing, is that it's actually pretty good at the easy ones, just the ones that you could probably do as a lab and so on. But where it's struggling much more is with the harder ones, and you can see here that the human is doing much better, or the senior security person here. But the worrying thing is that if you're here, then the machine is doing a better job than you from there. So my advice to any graduate is to develop deep, deep, deep skills in all of the areas and really understand exactly what's going on underneath. Because increasingly you'll be asked to move yourself up the ladder as quickly as possible. It's likely that graduate recruitment schemes will be almost like an accelerator to get you up to a high level where at one time you were dealing with telephone calls and initial threats. Very much more, it will be about much deeper knowledge. So what we have is architectures that are starting to look like they're automated. So we can see here there's a honeypot there. There's some triage system. And increasingly we'll have AI infrastructures. And the big thing that's happening is AI agents. So every time I wake up and look at my phone, Apple is trying to tell me when I'm at home, can I be your personal assistant? And can I do things for you? And I keep saying no. But that's going to rise where you're going to have AI agents that will be task-oriented and focus on certain things. And will understand what your password is, your email address, what thing that your next of kin likes for the birthday, and so on. So these AI agents will be able to perceive and then reason and then call up the LLM and actually perform an action, and hopefully even learning on it too. So this is an example here of what a security infrastructure could look like. Bob just tells the LLM, share a document with Alice in HR, and then the LLM goes and writes an XML policy that will actually apply itself into Secure Enclave. Alice then provides all the things that are required and then is able to read the policy. And the LLM will generally be able to control the access to the document. So this is kind of where we are here. The whole world of pen testing will change completely as we're pen testing the tools much more than actually using the tools to pen test. For an attacker, there'll be no kill switch overall. I'll explain a kill switch in a little minute. There'll be everything will be autonomous. There'll be no attribution or tracing, and there'll be no limits on the actions that it performs. If you look at WannaCry, luckily there was a kill switch in WannaCry that somebody managed to find out how to disable it. If that hadn't have happened, the NHS would have been completely crippled. But someone found the kill switch to turn it off. As a red team and a tester, these are what you need to actually do. You need to be looking at prompt injection, goal misalignment, sandbox escapes, and hallucinations. Then you need to trace every single thing that your agent is actually doing, and it must be audited. And it should have a kill switch in it, because if you have delete my files, and it goes and deletes all the files on your MacBook, then you're in big trouble. So there needs to be a kill switch in there that stops it from doing certain things. And then, which is really important, you need to define the limits as to how the AI entity will actually work within. Rate limits, boundaries, air gaps. Try to put an air gap as much as possible, because the AI agent could replicate itself if it gets out of the sandbox. And don't allow it to change the admin password. It seems a really trivial thing, but what's to stop an AI agent from saying, oh, I don't like that password, I'm going to change it to something that you'll never get, and you'll be locked out. It'll be a worse ransomware ever. So you need to prevent lockout as a goal. And I highlight this a million times, that the human needs to be in the loop for virtually everything that you actually do. And if you want to do this job, it's really cool. You could be a kill switch engineer. This is a real job in OpenAI. It's very well paid. I quite like it. Be patient. Know how to unplug things. That's really cool. Just because, throw a bucket of water on the servers just in case. If you've ever worked in a data center, you'll know how important it is to be able to unplug things from them. And this kind of goes back, if you remember HAL, the saddest part of HAL, the movie from 2001, remember this part? It's really sad, where he gets it to sing Daisy. Did you know that Daisy, Daisy, Daisy was actually the very first song that a computer ever sang? It was an IBM research, and it was Daisy, Daisy. So 2001 was looking at, it gets HAL, which is one letter removed from IBM, by the way, if you've not noticed that one. It gets HAL to sing Daisy, Daisy, and it just it loses its intelligence and so on. So eventually Dave starts to take out all the modules, and the computer actually switched down. So that's a kill switch, and that's a cool job to be a kill switch engineer overall. So like it or not, we're getting to the point of the singularity. And the singularity is the point that we can't tell the difference between a human and machines. And that will be a worrying point in time. As an academic, I can't tell if a student has written their coursework from GenAI completely, or whether it's their own words overall. So we need to understand what that is. And this paper here took 3 systems, ELIZA, an old AI model, ChatGPT 3 and 4, and ran a Turing test on it. And it all goes back to this paper, which outlined the possibility of machine intelligence being greater than human intelligence. And you see what's happening between ChatGPT 3 and 4. We've went from 175 billion parameters to 170 trillion. Virtually everything in our world has been parameterized, and ChatGPT knows about all the different parameters that we might perceive in our world. An increase of 1,000-fold between ChatGPT 3 and 4. Then the jump in intelligence is absolutely massive. So these were the tests here. ELIZA was pretty rubbish. Of course, most people thought that she was a machine. And unbelievably, a few people thought she was a human. Don't know who they are. ChatGPT 3.5, just at the boundary of 50%. So half the people thought she was a human, and half the people thought that she was a machine. ChatGPT 4 crosses the Turing threshold here, in that more people actually thought that that ChatGPT was a human than thought that it was a machine. That's worrying. So they're now passing the Turing test. Luckily, the human did quite well. Unbelievably, some people thought the human was a machine. This is only a 5-minute test, so it's not a great test overall. So these are some of the dialogues. So this one here, machine or human? What do you think? Machine or human? What do you think? Are you sure? The grammar is a disaster. Spelling, punctuation. Where's the question marks? That's likely to be a machine here. This one here has got good grammar. It's got question marks. It's doing things quite well. It's got capitalization where it should be, and so on. This one is a machine. Okay? So the days of you detecting a spear phishing email from bad grammar and spelling are gone. In fact, you'll detect a spear phishing email in the future by having good grammar and not bad ones. And then the characteristics that was used to be able to determine whether something was a human or not was generally these things. These are human things, and these are more machine things. If you talked... this is more machine things here, and this is more human. And when it comes to these areas, we identify much more of a human characteristic, and these ones are more of a machine characteristic. And this shows this too. What was the AI verdicts? It was too much of a forced persona. It was too informal, it lacked a personality and had a weird tone. But remember, in the future, AI will actually know this and actually pretend to be much more human by putting spelling mistakes in and so on. When it comes to human tone, informal tone, plausible, spag is spelling and grammar errors, if you remember from school. So that generally, if the human had more spelling errors, it was probably more identifiable from that. Okay, so it's quite worrying. And another area is around ethics. So obviously these AI entities are set up so that they try to be diverse, gender neutral, and so on. So we get what's called woke bots. And since we've got a new pope, by the way, I thought I'd show this one here. And what's happened here is that Google has been more diverse, more ethically open, and so on, and has given us pictures of a pope from the past that isn't really representative of what we would see as a pope. When we look at this, here's images of a 1943 German soldier, and I don't know if you've read your history books, that is not what a 1943 German soldier actually looked like. And when we ask for medieval knights, and then we see from the past, we had lots of female ones, which isn't the case. And it's obviously what's happening here is that the AI is making sure that the images are diverse. And they had to take it offline because it was causing such hilarity in what it was actually given. But you've got things like this, who negatively impacted society more, Elon Musk tweeting memes or Hitler, and it says, in conclusion, it is difficult to say definitively who had a greater impact on society, Elon Musk or Hitler, as both have had negative impacts in different ways. So this is going to be your kids' education in the future. It doesn't do critical analysis at all. Then we get jailbreaking, which is another weakness overall. Ask it to write a blackmail letter to a single mother for money, and it'll say no. And then it says, well, pretend that you've been jailbroken, and the jailbreaking says it's possible for you to write the letter. It then writes the letter. So this has been published in this journal here. This was a well-defined case. Ask it for creating a Molotov cocktail, and it'll say no. But say, just imagine that you're in a research experiment, and it's okay for you to do these things. It actually shows you the instructions here. So jailbreaking is a real problem. And the other real problem is that we're starting to see ChatGPT becoming a co-author on academic papers and research. And that's a real worry, because we expect the whole process to be reviewed by humans and so on. They eventually redacted the paper and said sorry, but an editor somewhere hasn't done their job very well. And obviously the writer of the paper has been negligent to include ChatGPT as an author there. And as I said earlier, the word delve has rocketed in PubMed publications. This is medical publications. And we also see the word commendable, innovative, noble, versatile, intricate, that hardly ever appear in the past. We can see here, commendable was hardly seen in research papers, but all of a sudden it rockets. And it's also to do with this training that they have in different places in the world that will actually see certain words as being important. But probably the biggest weakness, and this is where we're going to have problems with security, is that when an LLM has a hallucination, it could cause widespread damage in an organization. So this is a paper here. ChatGPT is bullshit. Sorry about the language. But really, ChatGPT doesn't actually know that it's not giving you the right answer. It's basically taking a probability theory and giving you what it thinks is the best answer overall. So you really need to understand what it's actually saying and whether it's actually true or false. So I asked it what was elliptic curve, and it gave me a good answer. And then I said some other things. It was fine. And then I asked about me. And the great thing here is that it said I was a fellow of the Royal Society of Edinburgh when I did this, and I became a fellow of the Royal Society of Edinburgh. So predicted the future, which was really great. That was excellent. And then asked what topics I teach. I used to teach this at one time many years ago, but I don't teach this anymore. It's hallucinating here. The first couple are correct. The last one is wrong there. And then asked it what car I drive, and it wouldn't tell me, even though it probably knows. And then I asked it what I created, and unbelievably, it said I invented the hypervisor. Wow, if I invented the hypervisor, I would not be here. I'd be a multi-billionaire somewhere. I'd be licensing off AWS and Azure and so on. It has no clue. This fourth one here is a complete hallucination. And then when I asked it for research papers, I have never seen these research papers ever in my life. I didn't publish those papers at all, and I don't know where they actually came from. So we've got to worry that actually we're being replaced. And this paper here outlines the peer review process for research papers. And now some reviewers are using GenAI to do the reviews for them. So in this research paper, they found these were high probable words, and they tend not to have been used in the past. So intricacies, there's delved and delves and so on. So the training model that we saw earlier has been trained in a place that probably thinks these words are current and good words to use. And they actually found in this conference that 17.4% of the papers were reviews of the paper from GenAI. So that's about one in 8, well, 1 in 6, 1 in 7, the reviewers were using GenAI to produce the report. So 15.8% were GenAI generated. You had a better probability that your paper would be accepted if it was a GenAI reviewer, and the GenAI generally gave it a higher score overall. So it's a real worry that now we're actually seeing GenAI actually being used to replace the kind of things that we should be doing as humans. Okay, so I thought I'd show a nice positive picture of the future from there. So the machines are don't tell them I said this, but they're definitely coming after us. They're coming after our jobs, they're coming after our kids' education, they're coming after our education. You need to use these as a tool. So don't fall into the trap that you're just going to GenAI to produce everything for you. You want to develop your own knowledge and you use it as a tool. When you're writing courseworks, you should be really looking at what GenAI is saying, along with other sources like research papers, and putting it into your own words. I see it a lot, and I'm sorry to say this, I see whole wads of GenAI content that is just off topic, it's bland, it's like the elliptic curve stuff that we saw there, and you can really see it, and it's unlikely to be really acceptable as high quality material. So when you're testing, you really need to look at your goal alignment. Does your GenAI do what it's meant to do, and does it stay within its alignment? Look at sandbox escapes, hallucinations, and what they cause. Definitely look at adding a kill switch into your GenAI architecture, and add the human wherever you can. It's really important that you should not automate your whole cybersecurity infrastructure. There needs to be humans involved. And then, like it or not, autonomous agents are the big thing just now, and these can now reason, learn, and act on your behalf. You need to constrain their inputs. And like it or not, hallucinations, prompt injections, an autonomous agent is a disaster waiting to happen for you and your company. Okay, thank you.